So is my board visible? Pins? Okay. So we discussed the last time. Let's see. We discussed the last time that the integer range is from in the positive side. It's like from till 2 to the power 31 minus 1, and on the negative side it is minus 2 to the power 31. And here's 1, 2, and 3 up to so on. So, but since there may be numbers larger than this range, so we discussed about the long whose range is from minus 2 to the power 63 to 2 to the power 63 minus 1. Okay, but there may be some answers, some values which may be larger than this. For example, we discussed last time that let's say if you compute like factorials. So let's say 10 factorial, it's like quite a large number, which is I think around, let me just calculate it. 10 per 6 is 7. Something like 6 28800. Okay. So see, 10 factorial is so much large, so you can imagine like 100 factorial will be greater than this range. This 2 to the power 63 is around like plus like 10 to the power 18 or 10 to the power 19, around this range. Okay, so 100 factorial, which will actually be larger than this thing. Okay, so there we cannot store the actual value, but for these kind of things, like in maybe programming questions, you will be asked to compute factorial of like such a large number, but in modulo with some other number, modulo some number, let's say x. So why is this done? First of all, see this model operator, I think you all will know that this gives the remainder. Let's say if something is like 1 second, something is like a modulo b is nothing but the remainder when a is divided by b. Okay, so as we see that this number is quite large, 100 factorial. So most of the time you will be asked to compute the factorial such as this 100 factorial modulo some x number. Why is this done? Because see, if x is of the range, let's say in 10 to the, it is in the integer range, or it is under 10 to the power 9. Okay, so this answer like whatsoever 100 factorial is, modulo x will always be like, if like the remainder when you divide by b, like the remainder can only range from 0 to b minus 1. The remainder cannot go above b or equal to b. The remainder will be from 0 to b minus 1 only. So if we take x as a less than 10 to the power 9 or in our integer range, so obviously this answer will be in our integer range, and you can like say something about you have got some answer. Because if you directly calculate like 1 into 2 and up to so on till into 100, then it won't make sense. It may be negative number. It will overflow definitely. So it will maybe negative number, maybe some positive number. So we cannot talk about this thing, but we can definitely talk about some bigger number modulo r like fixed x, so that the result is in our range, in our integer range or in our long integer range. Okay, so that's why modulo operator are used. And in general, you will find that questions that x is equals to, most of the time it is given 10 to the power 9 plus 7. So this number is generally used. This is a prime number, quite a large prime number, 10 to the power 9 plus 7. This is used so that you can give your answers in this range only. Okay. So now we'll discuss some properties of this modulus
Excuse me,
operator.
sir. I have one doubt. It is 10 to the power 9 plus 7 means 10 to the power 16 or
No, it is like 10 to the power 9. Like I'll write this number for you. X equals to like 1, 2, 3, 4, 5, 6, 7, 8, 9, and then a 7 is here. Okay, so 8 zeros and 1 7. This is the number, and it's actually a prime number. Okay,
prime?
this is a prime number actually.
Okay, sir.
You know what prime number is?
Yes, sir. I know a prime number, but it is too big to be prime.
Yeah, yeah. There are infinitely many prime numbers. So this is like one of the primes, and it's quite large. So generally in the question, when you are asked to compute a large number, you will be asked actually to give the answer modulo something. Okay. So now we shall discuss the properties of like modulus operator. So let's say you want to compute some addition. First of all, let me just write here rules of modulus operator. Okay. So let's say you want to find like a plus b, and let's say mod x. Okay. So see that this expression expands to a mod x plus b mod x and whole mod x. What it represents is like, suppose these are already a and b are already great, like more than they are already out of range. Okay, or integer or long number. Okay, so we need to find a plus b modulo x. So what you can do is do a modulo x and b modulo x, then add them, and then you can do like modulo x. Suppose a is like 2 to the power, like we have long and range as let's say this thing 2 to the power 63 minus 1. Okay, so let's say you have written that a long int a something and long int b something. So let's say both are 2 to the power 63 minus 1. Okay, and b is also this thing. So this a plus b, you cannot directly like do a plus b and then take mod x. Okay, this will overflow because its answer will be like 2 to the power 64, but this we cannot store. Like you cannot just do a plus b modulo x, because first a plus b will be computed and then modulo will be taken. So while computing a plus b, the your computer won't recognize this 2 to the power 64 minus 2. It will just repeat that circle that we discussed and compute some negative integer for you. So what you have to do is like first take a modulo x and make a in the range of x. Like now a modulo x is something between 0 to x minus 1, and now b modulo x is something between 0 to x minus 1. Then you can add both, because even adding this will give you like at max 2 to the x minus 2, which will obviously, if x is in the range of integer, 2x will be in the range of integer if it doesn't touch our boundary line. Okay, then you can compute something modulo x. So this is the property of modulo operator in addition, which help us to add and take modulo. If let's say this property wouldn't have been valid, then we could not be able to do a plus b modulo x. That will be very tough for us. So this property is valid, so we can like use in such type of cases. Okay. So next multiplication. So next we have here is that let's discuss the multiplication. A into b, let's say modulo x equals to a modulo x into b modulo x and whole modulo x. Okay. So now let's just get back to our example of calculating 100 factorial. Okay. Now how can we calculate 100 factorial a modulo x? Because you cannot store product in some integer. Like if you want to store like I will iterate from I equals to 1 to I equals to 100, and in like say fact some variable I will store continuous product of these integers, then I will take modulo. That will like lead to wrong answer because you will ultimately get some negative integer or so, and that is not the correct way to do that. So the correct way is like, as this property helps us, like for the product of two integers modulo something, we can actually take a modulo x into b modulo x modulo x. So we can apply like, let's say you have any number like let's say 1 into 2 into 3 up to so on. Let's say at some point this number becomes like 10 to the power 5, and you want to multiply, let's say it becomes 10 to the power 10, and you want to multiply with like, let's say next number is like 21 in your from your iterations from 1 to 100. So what you can do is take this number, let's say it's a, and this number is let's say b. So you take a modulo x, convert this higher number to a range which is below than x, take modulo with this number. Obviously like it will remain like 21 if x is like 10 to the power 9 plus 7, and then you product both, and then again you take modulo, so that till now your answer remains in the range of x. So let me just show you like what we'll be doing. Then let's say it is in fact will be your answer. So we start with 1. Let's say we want to calculate factorial for factorial till 100, factorial of 100. So this is our for loop. So usually we do that a fact equals to fact fact into I. So now we won't be doing this, but we will be doing that fact equals to fact, let's say modulo rx, let's say int x equals to 1 in 9 and x plus equals to 7. So this into I modulo x and whole modulo x. So on continuous taking modulo operator continuous on the product will help us to achieve 100 factorial modulo x. Okay, if we would have been doing something like, let me just calculate like fact into I, and then in the end I will take fact equals to fact modulo x. So that will be the wrong result, because you wouldn't have been calculated like that. You like this fact wouldn't contain 100 factorial because of the like overflowing and repeating that circle again and again, which we talked earlier. So this repeating circle will cause you a computation of wrong result. So this is the modulus operator in case of multiplication. Okay. Or even let's say you can calculate like 15 factorial maybe in integer range. So even let's say question says to multiply 15 factorial and 16 factorial and give its product. So it isn't advisable to calculate just 15 factorial into 16 factorial modulo x, but you should first calculate 15 factorial mod x, 16 factorial modulo x, and then calculate the whole modulo x. So are these two properties clear till now?
Yes, sir.
Okay. So
and one more thing, like if you are doing this way, right? If you are computing one a into b modulo x, like a modulo x into b modulo x, make sure that your x is in range of 10 to the power 9. If it is greater than 10 power 9, then also you cannot do this way.
Sir, but what is the logic in that?
The logic is that you can think if x is of range 10 to the power 10, right? So what will happen? A mod x, that will be something of the range 10 to the power 10, right? And b mod x, that will also be of range 10 to the power 10. And when you are multiplying two numbers of range 10 power 10, probably you will get something which is of order 10 power 20, and that you cannot store. At max, you can store only 10 power 18 range. So whenever you are doing multiplication this way, make sure that your x, the number by which you have to take the modulo, must be less than or equal to or some order of 10 power 9 only.
Yes, sir, understood. Thank you.
Okay, so the next property for
Subtraction.
subtraction. So in case of subtraction, let's say we want to do a minus b modulo x. So this will be equal to a modulo x minus b modulo x plus x and then again modulo x. So these two terms are like will be familiar to you, like as we did in a plus b or a into b, but we are adding a plus x already here. So why is it happening? So let's say take a very general example, like a is 6 and let's say b is 4 and your x is 3. So you want to compute a minus b modulo x. So what is a minus b? We know it is 2. So 2 modulo x. So the answer should be 1. Oh, sorry, 2. But if you do it in this way, that you take a modulo x first. So 6 modulo 3 will be 0 and b modulo x, which will be 1. So it is minus 1 modulo 3. On your compiler, it will give 1. Mostly, yes. 1. So it will differ from your result of 2. So this happens because a number greater than something, let's say a minus b is some positive result. So let's say assume that a is greater than b. So it isn't necessary that a modulo x must be greater than equal to b modulo x. That depends upon x and its remainder. So this might result in a negative number, and taking till here and taking the modulo with x will give you a wrong answer. So what we do that, see that we just add an x here. Let's say you have a number a which is less than equals to x. Okay. So for like we want to compute a minus b modulo x something. Let's say a minus b is already this small a. Even if we add an x extra to it and take modulo with x, what will the answer will be? A mod x plus x mod x from our addition property. So the answer, see, x mod x is 0. So answer will again be a mod x. So there is nothing harm in adding an x while taking modulo. So you can, and since this negation will be in the order of like minus x minus 1 to x minus 1. So adding an x will definitely make it positive, and then you can take modulo operator. Don't add x here. Add x after taking modulo from both the numbers. So I think this is clear with this example, or shall we discuss some more examples so that it is more clear? Is this clear? This modulo in the case of subtraction.
Sir, can we apply modulo for negative numbers? We can't know, sir.
On negative numbers, you can apply. Your compiler will give some results. Let me just like screen share with you. As you can see, let's say, let me just take. You can see my code, na? So So int, let's say, is minus 1 and int y equals to 3. Let me store int z equals to x modulo y z, z. So when I run my code, just a second. Oh, sorry. Okay, so it's minus 1. It will give some modulo remainder definitely. Let's say if it's even minus 9, it will I think give 0. If it's like minus 10, let's minus 11. So it will give minus 2. It will give you a remainder, but see, it is negative. Okay, so as we discussed, in this case, when we are negating a minus b, let's here, yes, a is 6 and b is 4, so answer should be 2 because 2 modulo 3, like it should be 2, but the answer will come out to be minus 1 on your compiler. But it depends upon compiler. It may give minus 1 or may give 1.
Sir, but how can
So,
remainder be
this
negative?
thing, it depends upon how how remainder is calculated.
Hello, Akash sir.
हाँ
Hello.
हाँ बता Prince. So remainder can be negative because see, for minus 1 modulo 3, the compiler is calculating like 3 into 0 minus 1 equals to minus 1. So it is giving you this remainder. For like, let's say if the number is minus 11, so the compiler is calculating like 3 into minus 3, which is minus 9, minus 2, which is minus 11. So it is giving you minus 2 as remainder.
Okay, understood, sir.
Okay. Sure, it will be in that range from minus x minus 1 to, you can say, plus x minus 1. Is there any issue with my sound?
No, sir, it's perfect.
Okay. This is the 3, let's say, properties on multiplication, on addition, and on subtraction. On division, this property doesn't satisfy. Directly, it won't satisfy. In further class, we will let you know how to calculate that. Let's say if you want to divide a by b and you want to calculate modulo x. So one second, yeah. So this is not equal to, let's say, a modulo x by b modulo x and whole modulo x. So this property is invalid. Let me show you how. Let's say you want to calculate let's see 16 factorial upon 15 factorial, and let's take modulo 3 only. Okay, so if you take 16 factorial modulo 3, as you know, 16 factorial is a product from 1 to 16, so it contains the number 3 itself, so the modulo will be 0, and 15 factorial also contains the number 3, so 15 factorial modulo 3 will also be 0.
Sir, first one.
So this, what?
Sir, the answer will be 1 now.
Calculating what?
Answer will be 1 now, like 16 modulo 3 will be there, so answer will directly be 1 now.
16 modulo 3 factorial, because you know how to calculate. But on your compiler, let's say I'm taking 16. Let's say while you will be calculating factorial, you won't be calculating directly the product and dividing that. I'm taking like if for this property, I am proving that this property is like I am just proving this statement which I have written that A by B. That A by B modulo x is not equal to A modulo x upon B modulo x whole modulo x. So if you have calculated 16 factorial modulo 3 already, let's say there may be like this number may be like 100 factorial. Even if 6 factorial fit 16 factorial fits into your integer end, 100 factorial won't fit. Okay. Let's say it is 100 factorial. Just skip this whole thing. Just take this now. Let's say it is 100 factorial upon 99 factorial whole modulo 3 you have to return.